Welcome everyone to today's Performance Clinic Automated Root Cause Detection for External Data with Dynatrace Davis AIOps. My name is Andy Grebner, and with me,
Wolfgang.
Here we go, Wolfgang Beer. Wolfgang, for those that don't know you, you've done performance clinics in the past, but maybe a quick word to yourself, what do you do?
Right, I'm product manager at Dynatrace already since 7 years now, and I'm owning the topic of the Davis AI, as we call it, which is the root cause detection engine that works on top of the topology.
Perfect. You've written a lot of great blog posts about how our deterministic AI works. You've created a lot of great presentations that really explain how we are using the topology data and then how we do anomaly detection. There's more great stuff that you're showing us today, but I can just encourage everyone, if you want to read up more from Wolfgang, go to blog.dynatrace.com, search for Wolfgang Beer. It's, in this case, you're allowed to Google for beer, right? I mean, that's funny, kind of a little bit. There's also your Twitter handle at Wolfgang B33R, I think is also the same name for your GitHub account.
GitHub, yeah, right.
Yeah, so you'll find a lot of examples from Wolfgang also on GitHub. Now, Wolfgang, before I pass it over to you, again, as a reminder, if you are live, please use the Q&A feature to ask questions. I will moderate. If you watch this as a recording, please either reach out to us through Twitter, through LinkedIn, or you just comment on the recording on YouTube or on Dynatrace University. I'm pretty sure you'll find a way how to get a hold of us. But now, Wolfgang, over to you.
Perfect. Thanks, Andy, for the introduction. And I'm very happy to be able to present the topic of Davis and external data and how to leverage our AI engine on top of that in our today's performance clinic session. So time is short, so let's dive right into it. What's on our agenda as of today? First of all, I will dive into a quick refresher on what dimensional external data is, or dimensional data in general, and how Dynatrace Davis can recognize your own data in topology. And in order to not annoy you with just slide decks, I also prepared a live demo where I'm monitoring my own Synology disk manager, because that's standing in front of me, right? With an external Telegraph agent and SNMP, so using Telegraph and SNMP in common together with Dynatrace, so combined forces, so to say, in order to extract information from my Synology topology and then ship that kind of information as an extension to the DAO for simplicity reasons. And then we will finally trigger a Davis root cause analysis on top of that information and see what the outcome is. And all that information is online in my GitHub repository, but I will show you that later. But jumping into the refresher. So what's the topology? What's dimensional data per se? So if you look today into the Smartscape topology, you see a lot of information in terms of the topology that is monitored in that specific environment. And it all comes and is extracted from raw data that is delivered from OneAgents, meaning logs, spans, traces, metrics are used in order to identify what we are looking at. And that means in large-scale single environments, we already see more than 600 million, nearly a billion entities that are monitored in real time in one single Dynatrace environment. Now you could say, well, 600 million hosts, I don't believe that, but that's not only hosts, it's about processes, individual process technologies, services on top, hosts, of course, the disks that are running on a host, even service methods, endpoints, service endpoints, or synthetic tests or test steps, all that counts as a monitored, what we call a monitored entity. And all that could be represented as some sort of a node in a graph. that has a connection to other entities. And now our goal for today is basically, if you look at our teaser that we sent out, it's very similar to a constant stream of data coming in, and without any schema on top, without any knowledge what it is, even the most simplistic metric that is dimensional, and I will show you later a real example of what I mean, really looks very similar to that matrix rain of data, as it is called. And the goal is that by applying Dynatrace and structure and topology on top, on top of that highly dimensional raw data, you gain semantics and meaning on top that you can work with, and that is human understandable in that sense. But what do I mean with dimensional data streams and dimensional data? I would like to remind you on tools and processes that you are used to. And so dimensional data is not a new concept. It's a very mature and long existing concept, a very wide and well-known concept. And you probably have found it in Prometheus metrics that are split by service methods or services or hosts. Or even if you think about Tableau or Power BI, or even Excel, I also use Excel as one example here, where you can easily put a pivot table on top of a huge raw data table in order to slice and dice the data according to the dimensions that you would like to see and that you are interested in. And that's pretty much the same what we are doing on top of the dimensional data that is streaming into Dynatrace, except that Davis does that in an automatic and real-time fashion. So instead of waiting for somebody to build a pivot table, we are doing that automatically all the time for all the information that is streaming in. So what do I mean with all the information that is streaming in? I mean, the term observability already mentions that scope that we are talking about. It's about metrics. It's also about logs, events, and of course, it's about user experience, data, and traces. So user sessions and traces. And out of that, as I mentioned, you can slice and dice into those reported raw dimensional information. In this case, I just showed a three-dimensional cube here, but in reality, even a Dynatrace custom metric that you can ingest can have up to 50 different dimensions per metric measurement, so per single measurement value that you send in. And out of that, we are automatically generating a topology out of it that shows the host, the process, the service on top, the Kubernetes environment, the workload, and so on. And that is all seamlessly integrated into our built-in UI, where you can see all those relationships. I will show you later on what I mean with that. Not only with those huge graphs in Smartscape that where you easily get overwhelmed by the sheer amount of nodes that you would have to look at. So the magic is basically to see all that incoming data, that raw data, in context. And what do I mean with that? Instead of reviewing one single stream of data that is streaming in, like a metric, you would like to see where the metric is belonging to and what the metric actually measures. Because the metric itself is an indicator for something, what we call a monitored entity, because that's why we call it a monitored entity, because the metric is sending some measurement about that entity. So what do I mean with all data in context? I give you an example of a typical host stream. I mean, that's a very traditional screen, but I will jump then to my example with a Synology disk and show you how you can do the same with your own data. So in this case, the monitored host, everything falls into a place and everything is shown in context. So a human operator immediately sees properties of the monitored entity. So for example, where it's running on, which architecture and so on. But it's also showing the metrics, obviously, a very important information here. But it's also showing Davis incidences that were automatically discovered and that were discovered over the historic period or are just open. Also, how long and if the entity is still available. So the availability is shown. And here you also see topologically relevant entities. In this case, for the host, we just show the processes. But it's not limited to the processes. You could show anything that is topologically related to that entity that you are looking at and that you are focused at. And I will show you that later with my Synology disk, where exactly I specify what I would like to look at and where I think it's important to see it in context. Of course, we also have events, so baselining events, metric-based events, external API events, and so on, that are coming in, OneAgent triggered events, and so on. And we have the logs in place. So everything falls into the place, and you have all the data in context in order to grasp what's going on.
Wolfgang, just maybe a quick interjection here. First of all, thank you for this. Already some questions came in. Okay. I want to highlight that if people are new to Dynatrace and want to know what data comes through an agent and what's the overhead of the agent, what about external data? So first of all, I have answered some of the questions already. I'm also posting links into my questions. So in case you want to learn about the OneAgent, Smartscape, and everything that Wolfgang just said, there's a lot of material already out there. Also, again, the session is recorded. I want to highlight this again. And if you have questions, please put it into the Q&A feature. And yeah, one of the questions that is outstanding is, do you give some examples on dimensions? Because you talked about dimensions earlier. Yes. I think you will. It's in the upcoming slides. So make sure you put in your questions. This is also proof that this is live. So put them in and we'll tackle this. Thank you, Wolfgang.
Perfect. Yeah, so I just gave a quick recap about dimensional data, all data in context, but now the question comes up. Yeah, we know it works perfectly with OneAgent data and with cloud integrations and VMware integration and so on. But what about if I would like to send in data? Is Dynatrace open to take that kind of data? And can I see the data? And can I leverage Davis to understand and to work on my data as well? And so what can I do with external data? Well, first of all, I identified 3 main use cases that you have to distinguish here. And that's very important to distinguish between those and where to start from. So the first use case is that you already have a monitored entity, like a host, a service, or an app that is running in Dynatrace that you already see in an entity screen or in Smartscape and so on, maybe given by the OneAgent, or you have a RAM application that is already running and monitoring user sessions. And now you would like to attach additional information. So it could be, for example, that you would like to add open telemetry information from a C++ kind of process and to stitch it to the OneAgent monitored service. Or what always, or what is a very traditional use case is that you have some sort of a proprietary technology running on a host, like a batch processor or something, and you would like to report some batch processing metrics that you collect onto that specific host. And of course, you can do that by just linking to the existing OneAgent monitored host by using its ID. And now the second use case, which is primarily what I'm speaking today, is about how can I create my own entities and entity types out of the ingested data. So let's assume I have a telegraph agent or SNMP or an extension 2.0 running that fetches some metrics from an SNMP data source or from Prometheus or whatever, and I would like to create my own entity on top, and I would like to name and to arrange that entity type, and also to ship that pre-built solution to an extension to the law. And that's exactly what I'm describing today, how to do that. And then there is the third use case. Of course, we don't have to forget that. Not always we need an entity, right? If you just want to use Dynatrace and to send in a business metric that is not related to an entity, you can do that as well. You don't necessarily need to create an entity on top. So you can use Dynatrace as a metric store or log store or event store as well. And then you just use the traditional reporting and charting of that metric on the dashboarding level and alerting, of course. But let's jump into what can you do with the use case one. I attached an example here where multiple data sources, like let's assume you have Prometheus here that is shown on top of the ActiveGate, StatsD, for example, or OpenTelemetry, Telegraph, or the API. Most use cases start with the API first because it's so easy to get started with an example. And you would like to attach it to an existing host. So you would like to attach a custom metric to an existing host. You see that here by the red square here, where I added the reference to the existing host, but you can add any kind of reference for service or application, whatever you want, and to attach, therefore, those measurements to that specific host. And ultimately, the metric is then attached to that host that you already see in Smartscape, and Davis will also take up your custom metric here during the change point and root cause detection. And if it shows any abnormal behavior during an incident, it will show up in the root cause section here as it is shown. So that's use case number one. And I use it, yes.
Yeah, just this is fascinating. So questions coming in, I have so far, I think I've answered all of them, but I also want to say, watch the chat window, because I just also posted the link to the metrics ingest API to the documentation. So Wolfgang, I will try as you go through, also post relevant information to our audience in the chat.
Cool.
But this is
Thanks
really,
a lot
it's exactly what,
out.
Yeah, of course. I mean, otherwise I would just sit here, right?
Yeah. Okay, use case number one, but use case number two. And now it gets a bit more tricky, but also much more power in that one, I would say. So use case number two is how to analyze data streams like a pivot table and what is a dimension as such. And let's see that in terms of an example here. Let's assume you have a metric that is called host.disk.free. So it's the percentage of disk-free percentage on a given host. It's a very simple example, actually, but nevertheless, you can grasp the idea of it. I send along the host name, like host A, host B, host C. I also send along the region as a dimension, so US East, US West, US South, and the disk as disk C, disk Z, and disk D, with different measurements for each individual disks. And now, if you take, and out of those three dimensions, because you have, in this case, you have three dimensions, which are host, region, and disk, you can span up such a three-dimensional cube as such, where each of the cells itself, as it is highlighted here, represents one host and one disk on a specific host in a specific region. And you can imagine that that can go into the 100,000s of different disks, different hosts, right, in a monitoring environment. And the reason for that is, and now the question is, how can I extract the topology on top? And the topology basically comes with the information that is delivered with such a measurement, such a metric measurement. So the information is shown with each individual line. So let's see those lines here and what dimensions and dimension values we can extract. We do see 3 individual hosts, namely host A, host B, host C, right? And we also do see 3 distinct regions in those measurements, which are US East, US West, and US South. And then we see 4 disks. And here we have to distinguish of the disk C seen on host A and disk C seen on host B, because the name of the disk is not unique. Probably you have a 30,000 C disks. The uniqueness of the disk comes in relationship with the underlying host. And that is shown here on the right side. The topology that you could extract out of it is the region, the host, and the disk that is running on top. And for one of those hosts, namely host C, we have 2 disks running on top. Okay? Out of that, I decided deliberately to only model the host and the disk as an entity. I mean, you could model the region as well, but I decided that host and disk is enough for me. And a relationship that I called is child of. So basically the disk is child of the host. So what can I use in terms of relationship that Davis understands or that we can use? There are some supported semantic relationships that you can use in your own topology types. So there is the instance, the family of vertical relationships. With vertical, I mean, it's the deployment stack. It's vertical seen from the running process, the running service, and its underlying resource providing technology stack. It's basically the deployment stack, no matter if it's a Kubernetes cluster or a bare metal host. And on those vertical stack, we have the relationship instance. So like a service is an instance, or a service instance is an instance of a service. A process is an instance of a process group, and a host is an instance of a host group, and so on. Or the runs on relationship, for example, where the process is running on a host. Or where the child of, you can imagine like a disk is a child of. The child of relationship basically doesn't contribute resources to the run entity, which is different from the runs on relationship. And then we have the important horizontal relationship, which is basically who calls whom, caller-callee relationship, like service traces and so on. So whenever a service calls a service, that relationship is used. I also have some use cases here that you can use. I mean, it's up to you in your own modeling. For example, the runs on relationship is used for VMs running on a vCenter or on a hypervisor. Or, for example, a pod running on nodes. A pod is an instance of a cloud application, is one of those runs on an instance relationship on the vertical stack. Or a queue manager is running on a host, and it's running multiple queues. So those are typical vertical use cases that you can model. Typical horizontal ones are services calling a service. A host is contacting another host through a TCP connection, and so on. So those are typical horizontal use cases. Okay, and now let's jump into an example. So you could now say, well, I believe it or not, but now I will show you an example that I did and that I will share with you, and where you get the hands on the code itself. So in this case, I decided some time ago that I would like to get some numbers out of my Synology disk, my network disk that I use at home. And I thought that the easiest way for me to do it is to run, because the Synology disk is able to run Docker containers. So what I did is I run a Docker container inside that Synology disk that automatically monitors the Synology network disk and sends the data to Dynatrace. Important, the material that I'm showing here is available on my GitHub repository. It contains, let me show you that here. It contains a description, how you use the whole extension here, how you can build the extension, and how you upload it into your own monitoring environment. And there is also, because maybe you don't have a Synology disk as I do, maybe you have, there is a load generator attached. It's a very simple Python script. It's self-contained. So you just have to enter your Dynatrace environment here and a token, and then you run it. And it generates the same data that my Synology disks generates and sends it to your, simulates it and sends it to your own monitoring environment. And I can also show you an example data stream from my own. So you see that, and it really looks a bit like that metric stream. So it's very hard to grasp the meaning out of it. But it's
just
really
need to have some, you just need to have some green background color.
Yes, right. and that's exactly what's coming from my Synology disk. And that is also automatically created every minute by that load generator here. Okay, jumping back to the example, what is the goal of the example? To summarize that first. The goal is that I would like to see my Synology disk manager as a specific type in Dynatrace. I would like to name it exactly, Synology disk manager. And I would like to have my Synology disks that are mapped on top running with a relationship on that Synology disk manager. And of course, if I have a second or third or fourth disk station sending in data, then of course those topologies should appear automatically. So the goal is to create two new entity types, namely Synology disk station and Synology disk, to automatically derive entities from SNMP data stream here, and to fill entity attributes from my SNMP data stream, and to derive a relationship out of that. So that's basically the goal. But I will show you now in my environment and how it's done in configuration. And that's pretty, or I show you the data first. So once you start the load generator and you enter the metric browser, then you see that you get some telegraph SNMP kind of data here. And if you open it, you see what this metric is about, and it's a percentage. It shows already the live data coming in. And because I already used that topology that I defined, you also see the splitting by Synology disk manager in this case. And for the disk metric, you already see a two-fold splitting in 2 dimensions here, which is the Synology disk along with the Synology disk manager. But how did I achieve that? Let's see the chart itself. That's the live data coming in. And you see, I can split by any kind of those dimensions. I mentioned before multi-dimensional data stream. So those are the dimensions. I have the serial number here of the Synology disk. And I have the model name DS280 plus, and so on. But I also extract automatically the Synology disk and the disk manager. So if I run and split that by a disk manager, I see the name of the disk manager, and I get a handy drill down into the disk manager screen. I will show you later. Let's stick to the first part, how to get the new type registered in Dynatrace. What we can see here from those raw dimensions is that I guess the serial number is a pretty good unique identification for each individual disk manager. So each disk manager shipped by Synology, I assume, has a specific unique serial number. And that's the reason why I use the serial number dimension to extract my Synology disk manager entity. And I will show you how to do that. So I head over to settings. I have my topology model here. We call it generic types. You go into the types and you see I already defined my Synology disk manager here. So basically you define the type name, syn disk manager, and the human readable display name of that type. You can also enter who created that or which extension created that. And then comes the magic. You add an extraction rule here. And the extraction rule is basically telling Dynatrace from which source you would like to extract that information or that entity. And here you already see that you can use metrics, logs, and spans in order to extract new entities, just like Dynatrace does with the Smartscape or with a host or with a process. In this case, I chose a metric, of course, but I go back to the pre-configured one. Let's see that here. I already have pre-configured that. I'm extracting from, let's stick to the second one. I pre-configured one that says, please extract that entity where the metric starts with telegraph.hr storage table. And that's specific for your own metric. I can't know that. You know that if you look at your data stream. I also extract from a second metric source, which is all metrics that start with telegraph interface table, which contains all the network kind of information that my Synology disk reports to me, and so on. So you can extract that entity type from multiple sources. That's basically the statement here. And you define which sources you would like to extract from. And then you can extract entity properties out of those sources. So for example, I extract the model out of the model dimension. I extract the serial number, the system name, and the version, and so on. Okay? And last but not least, I even tried to extract, I even tried to extract the same entity by sending in log lines coming from my Synology disk, which you see here. So I'm also extracting the same entity from a log line. So whenever my Synology disk logs something, like a Docker container was started and a log entry is written on my Synology disk, the log entry is enough in order to create an entity on the Dynatrace side. Okay? Typically, yeah, you are extracting from multiple sources.
Mm-hmm. Hey, Wolfgang,
Yes.
there's a couple of questions that came in, but one is just perfect now. It says, why use this generic type approach versus custom devices? We had custom devices for a while. So why use the generic type approach versus custom devices? What are the pros and cons?
I will show you.
Perfect.
Yeah, maybe that's perfect time to jump into that. Let's see.
Also, maybe keep it in mind, maybe to cover this, yeah.
No, it's a perfect time to jump into that. Why would you configure that? The reason is that you can react individually based on the type here. So one very minor example here, but it helps you tremendously to work with Dynatrace here and with the data in context, is that I can type in here Synology. And what you see here is your own chosen type name. So it's no longer a custom device for all things that you send in. It's really a named Synology disk manager that shows the name and the proper link. And now we jump to that screen for that disk manager. And you see it's a pre-configured screen that is specific for that type, for that disk manager type.
And I think this is the power here, right? Because it's really you can define what do you want to see. So you are extracting an entity out of individual line items with the logs, where you're pushing in metrics, and then we create an entity based on the dimensions on the affiliation, and then we automatically generate this individual views that you can even then customize, I think, right?
Exactly, and individual lists and breadcrumbs for the navigation.
Yeah.
And this screen, for example, is configured by me through the extension 2.0. And you find that in my example. I will show you how to do that. And it shows you the properties of the entity. You see the host, the serial number, the version, everything that I decided to extract from the data stream. And by using multiple data streams like a log, a span, a metric, you can combine and merge properties that are coming from different data sources. So maybe you just get the host or the version from the log file, and it's not available through the metric. But on the entity level, you can join it, and you see it in context, and it's merged into an entity.
That's really cool. Now I see from the URL on the top, it says custom device. So
yeah, it's still
behind
the
scenes, it's still the custom devices. Yeah.
Yeah, exactly. So we needed an ID anyway, and we just used the custom device ID for simplicity reason. But otherwise, it's a completely typed entity. And even you will realize, I mean, the time today, it would explode the example. But on the entity v2 API, you can even use the disk manager type in order to fetch all disk manager instances. So you don't have to fetch for all custom devices. You specifically fetch for your type and for the instances of your type. And here you can see what kind of relationships I defined. And you see, I even set a specific icon for that type. So I use that network type icon here and the disk icon here for representing the disks. And you can set that through the extension 2.0 as well. And you see the disks that are running on my Synology disk.
Hey, Wolfgang, one more question that just came in. When was extension 2.0 released with the generic types?
Actually, I think it was 218. You find it in the documentation.
218, okay.
And there is a tutorial how to do that. And that perfectly leads to my last part here. I mean, you wouldn't configure that by hand. Maybe for the demo purpose, you would do the configuration in Dynatrace in the UI. But otherwise, if you would like to build some technology support, you would build it and ship it through an extension. And that's shown here. It can be done by a simple YAML file that is shown here, where you simply define the topology. You define the same information that I showed in the configuration UI, like the type name and the display name and so on, and the extraction rules. So maybe it's even simpler in the YAML as you just have to enter the sources as metric, being metric, and the condition is prefix telegraph.snmp. And then you copy that line and you attach and extract from another source. And the relationship is pretty simple. You say, I would like to do a runs-on relationship from the disk to the disk manager. So the disk runs on the disk manager, and I would like to extract that relationship from the HR storage table metric. That's all that is necessary. And then automatically, all disks that you map automatically on the Synology are appearing in Dynatrace automatically. Last step is you compile the extension and you upload it, and the screen will appear automatically, pre-configured. And maybe I show you now very quickly how that extension looks like. I mean, you find it in the GitHub repo anyway. That's the topology definition. So that's the disk. And what's also nice is that you can configure the screens. So you say the screen for my disk manager looks like this. I would like to show the problems. I would like to show the properties, the tags, and so on. And I can define even the chart group with the metrics that I would like to focus the screen at.
And just to reference, so you showed us earlier this stuff in the Dynatrace UI, and this is basically just the YAML representation of that configuration. Yeah.
For easy shipping, because I don't want, if I ship it to your environment and you ask me, Andy, please deploy it to my environment, then I don't want to configure around and do some copy and paste errors. I built an extension.
Perfect.
And I can show you here how to build the extension very quickly. So basically, you need certificates for that. You first use the Dynatrace client tool that I referenced in the GitHub repo. So I use some, define some passphrase here. Care about that. And the certificate already exists. Sorry for that. And then I do Dynatrace extension build in the same directory where the extension YAML that is shown above is located. You type in your key passphrase, and the extension is built successfully, and you find the zip here in the same directory. That's all you have to do. And then you upload it along with your certificate to your Dynatrace environment in order that is trusted, otherwise it wouldn't run, right? And then you can use it.
So, but the extension really is just, I mean, a set of rules that Dynatrace then analyzes based on incoming data, but we package it into an extension that then has the additional information about how to display the data. But yeah, this is basically what it is, yeah. Cool.
And there is a lot more to come in that area. So far, the documentation for the extension 2.0 is a bit rough, I have to admit. But there will be some examples and more documentation to come in the next couple of days. And it's really a powerful mechanism.
I suggest we do another performance clinic, maybe just on the extension 2.0. Who would I reach out to?
With a PM of the extensions, of course.
Yeah, exactly. Hey,
but
before
now,
you go to the anomaly detection, I just want to answer one more question. Mariusz is asking, is it possible to attach metrics from custom stream to existing AWS RDS instances? So I think the answer is yes, because you can attach any metric, any
Yes.
external metric to any entity, even if this entity comes in, let's say, through our AWS integration.
Yes, exactly. So you just have to reference the API ID of the monitoring entity, like the RES ID, and then you send it in through the Mint ingest or the line protocol, and it's automatically attached. Now, last part is how to detect anomalies. First of all, a quick refresher, how that's done. So we recently introduced metric expressions. There was a performance clinic on that. You can go back to that one and look at that because it's a tremendous, powerful feature. But the point is that you can use any kind of metric expression in order to create a query that results in one or multiple series. And on top of that, you can define either a static threshold or an auto-adaptive baseline that is then automatically evaluated, and that triggers an event, a trigger event that triggers Davis whenever that baseline or that static threshold is breached. And that basically is the trigger that Davis needs in order to trigger something on your Synology disk, for example, on your device. How would you do that? Well, in the case of my telegraph, I would, for example, select the CPU user metric, CPU usage metric, and I split it by my Synology disk manager entity, and that's important because the splitting by Synology disk manager identifies the entity itself. Otherwise, it would be one aggregated line. You can copy that directly from the Data Explorer over to the anomaly detection configuration as is shown below. And Davis uses that cohort that you selected and automatically suggests a threshold here already that is done on the last 24 hours of incoming data. It also shows how many individual series that Davis is then monitoring automatically and that is alerting on. And then your custom event is raised based on those series. Okay, so how would I use that for my Synology disk? Well, first of all, if you don't split by any dimension, then you get an alert on environment level. If you split it by Synology disk manager, you get the alert raised and the root cause detection triggered on the Synology disk manager. If you split by Synology disk manager and Synology disk, then the anomaly detection and the event is raised on the primary entity here, which is the Synology disk, as it is living on top of the disk manager. So that's automatically selected for you. In case you don't want our automatic selection, then you can override that in the configuration by selecting what is the primary entity you would like to raise the alert on. Now, coming to the end, I would like to now show that it actually works as I presented it. So jumping back to my environment again, and let's see, I already did, or I started first. So what I do now is I give you a glance on my Synology disk here. And as you see, refresh the screen. It's running Docker containers on top. And as I said, there is the monitoring Docker container running on. And in order to make the Synology disk do some special stuff, I decide to download a Magento image for no specific reason. other than to increase the network load and the CPU consumption on my actual Synology disk. So now the Synology disk starts to download those two images. They have 1 gig around, and the CPU starts to rise here. And I will show you that I configured a baseline already that should cover those anomalies on my Synology disk. So you see that here. I created high CPU usage on Synology storage. And it's basically using my custom metric here, and it's split by Synology disk. I already triggered one today to test it out, but you see that here. And we will see that in a minute. And I will also activate an alert on disk, on individual disk level. And now heading back to my Synology screen. 5 minutes left for me, so I hope it will pop up in time. You see that rising of my metric already. So the reason for the rising of the CPU usage here, you see that the memory doesn't really rise, but the CPU rises because my Synology disk really starts to download those Magento images and uses some disk space underneath. And within a minute, we should actually see a Davis problem popping up, hopefully.
Hey, while we're waiting, there's a couple of questions that I couldn't answer yet, or I haven't had the time yet to type in. The first one, I think I know how to answer, coming back to the AWS RDS example. If you're sending data to an existing AWS RDS instance, are they showing up in the UI? I think they don't show up in the default screens because the RDS screen is very specific and it doesn't show any additional metrics on that screen, but obviously you can chart it through Data Explorer.
Exactly. So you can chart it, you can dashboard it, and there is a large effort going on our side to replace the built-in screens with that flexible screen that allows you to also show your custom metrics and your custom logs on top of such a screen. And that means, I think the next step for us is to replace the host screen and the PGI screen with exactly that same screen design that I showed you before. And that gives us the flexibility to also show your custom metrics on the built-in screens. But that will still take some time. While we are the problem already opened. So you see that, but it's still, let's see. No, it's already there. So we got the alert on the Synology Disk Manager, as you see here. We saw some configuration changes coming in through events that Davis picked up through the root cause detection. Like I called it Docker container start. That Docker container Magento was started. You see the event here. So our baseline event, and Davis automatically performed change point detection on all those custom metrics that you sent in. And those are shown here. And you see that spike here that is identified in all those incoming Telegraph metrics. So whatever custom metric you're sending in, Davis not only uses the trigger event here, but it automatically traverses the topology in order to check each individual metric on top. And you see now that Davis is already in the process of merging individual disk alerts onto a visual resolution part. I clicked too fast, I guess. But you see that on the individual disks, the alert was, the events were also raised on the different volumes, because I forced that actually. And Davis already picked that up and merged into the into a consistent problem.
It's funny. This was actually exactly one of the questions. So how does this work? Would you then get different alerts, or do you actually aggregate it up? And we do aggregate it up because we know the dependencies. And the same is true also for another question came in. If you have your disk example and you have a service somewhere and that service experiences a slowdown, but the root cause is the disk, can Dynatrace detect the root cause? Yes, we can, because we have the dependency information, right? And this is the uniqueness of Dynatrace. It's not just metrics that we correlate through timing, but it's true correlation and causation because of our dependency information.
Exactly. I'm just waiting until the processing is finished.
Maybe while you're waiting, there's one more question. There's a couple of questions that came in around SLOs and how SLOs fit into this. Right? The way I explained it, if you have your SLOs, your service level objectives, let's say availability on a service, and then this service is using another service, and this is on a host with your disk example, then in your disk has a problem, then we would say, hey, there's a problem here. We detected it fully automatically, and we know there's an SLO defined up here that you're reporting against. We actually mark that SLO as potentially becoming impacted, even though maybe it's still available, but there's an open issue that Dynatrace Davis detected. And this is, again, the next cool thing. It's like, I don't want to take credit for this, but one of our colleagues, he said, it's like a, think about Minority Report pre-crime. So we know you have an SLO up here, and we know there's an issue already that we detected because of an anomaly. And if we act now, you prevent the SLO from being impacted. If you don't act now, well, you'll have a crime scene.
Exactly.
Yeah.
And so now everything falls into place. You see that you provided that Synology disk type. It's shown all over with that human readable name and with that type and with those icons in the Dynatrace UI. Davis picks that up and shows that in a consistent problem pattern. Yeah, and with that, I'm at the end of my demo. There's a lot of useful resources online, like as Andy mentioned, predict SLO violations and to pinpoint root causes by using Davis, or to detect outages within your custom data streams, and metric expressions. There is a great performance clinic done by a colleague of mine that you should watch. It's really great performance clinic on metric expressions. And with that, I'm at the end exactly in time.
Yeah.
Andy, you didn't believe me.
It's amazing. Yeah, you did a great job. And I wanted to say, first of all, thank you. I hope to have you back soon. And it seems I need to reach out to, you need to tell me who to reach out to in terms of the extension 2.0.
Yeah.
The second thing is the session was recorded. It will be put on YouTube and Dynatrace University. The slides will also be put up on Dynatrace University. What I'm doing now very quickly, that as I've done earlier, I'm just quickly sending you the links that Wolfgang had on his last slide, the additional resources in the chat. So for those that are still there with us, you can also just, here we go. I guess I copied this twice. Sorry for that. One more. Yeah, and if there's more questions coming up, you have our names. You can also kind of defer our email address if you know our names and you know how Dynatrace emails work. But, you know, we also have the university, answers.dynatrace.com, our community, many ways to get in touch with us. Cool. Wolfgang, I think you deserve a beer at 6 o'clock in Austria or whatever your beverage is of choice. I will probably have another coffee here in Seattle before I jump on the plane home.
Perfect. Safe travels.
Thank you. And thank you. It was awesome.
Thank you.
Bye.
Bye-bye.